வணக்கம் நண்பர்களே. இன்னைக்கு வீடியோவில் நம்ம என்ன பார்க்க போகிறோம் பார்த்தீங்கன்னா, எலக்ட்ரோமேக்னெட்டிக் தியரியில் யூனிட் 5ல் செக்ஷன் 2 தான் பார்க்க போகிறோம். ஆல்ரெடி போன வீடியோவில் செக்ஷன் 1 பார்த்தோம். என்னென்னு பார்த்தீங்கன்னா, எலக்ட்ரிக் ஃபீல்டுனா என்ன, காஸ் லானா என்ன, கூலும்ஸ் லானா என்னன்னு பார்த்தோம். வாங்க நண்பர்களே, இன்றைக்கி ஸ்ட்ரைட்டாக நம்ம வீடியோக்குள்ளே போயிடலாம். லாஸ்ட் வீடியோவில் சம்மரி என்னென்னு ஃபஸ்ட்டு பார்த்தலாம். நம்ம இன்றைக்கி வீடியோ பார்க்குறதுக்கு முன்னாடி கூலும்ஸ் லானா என்னன்னு பார்த்தோம், எலக்ட்ரிக் ஃபீல்டுனா என்னன்னு பார்த்தோம், நெக்ஸ்ட்டு காஸ் லா, தென் அப்ளிகேஷன் ஆஃப் காஸ் லா. இதெல்லாம் லாஸ்ட் வீடியோவில் சம்மரி, இதெல்லாம் லாஸ்ட் வீடியோவில் நம்ம டிஸ்கஸ் பண்ணியிருக்கோம். ஓகேவா நண்பர்களே? பார்க்காத நண்பர்கள் லிங்க் டிஸ்கிரிப்ஷனில் கொடுத்துருக்கேன், பார்த்துங்க நண்பர்களே. அப்போ லாஸ்ட் வீடியோவில் நம்ம என்ன பார்த்தோன்னு பார்த்தீங்கன்னா, கூலும்ஸ் லா. அப்போ how to define Coulomb's law? Just I have to recap. Okay, then Coulomb's law na that should be a then F is equal to 1 by 4 pi epsilon naught then Q1 by Q2 by R square. Okay, this is the Coulomb's law. How to define then Coulomb's law? The force between the 2-point charge is directly proportional to the product of charge and inversely proportional to the square of the distance between them. இதெல்லாம் நம்ம லாஸ்ட் கிளாஸ்லே நம்ம டிஸ்கஸ் பண்ணியிருக்கோம். ஜஸ்ட் ஐ ஹவ் டு ரீகேப். ஓகே, நெக்ஸ்ட்டு வாட் இஸ் மீன் பை எ எலக்ட்ரிக் ஃபீல்ட். ஓகே, தென் எலக்ட்ரிக் ஃபீல்ட் ஹவு டு டிஃபைன். Just I have to revision for that last video about how to write the electric field. Then E is equal to, there should be a F by Q. Okay, F by Q. But here what is the F? That should be a force. Q is the charge. Okay, then E is the electric field. Then what is the unit? The Newton per coulomb or volt per meter. Okay, next one Gauss law na enna pathom. Okay, appo what is meant by a Gauss law? How to define Gauss law? That should be a then pi is equal to then Q by epsilon naught. Appo how to define Gauss law? That should be a then total electric flux. That is the important word. Okay, electric flux. Okay, the total electric flux of the field, that is electric field, then E over any closed surface. Okay, that is the important word. Closed surface is equal to 1 by epsilon naught of the total net charge enclosed by the surface. Okay, these are all the cases we have to discuss in the last video. Next, application. What is meant by application of Gauss law? First cases என்ன பார்த்தோம், infinite. Okay, இப்போ infinite plane sheet of the charge எப்படி இருந்தா, how to define electric field? Then E is equal to sigma by 2 epsilon naught. Next secondல two cases இருக்கு. One is that should be a then parallel sheet. Okay, then parallel sheet of the charge la two cases A and B. First one is if the charge is equal in magnitude and same direction. How to electric field? Then is equal to sigma by epsilon naught. Second case, equal in magnitude and opposite direction, then electric field is equal to 0. Then third one, then electric field is a spherical symmetric charge distribution. Okay, that should be a then spherical symmetric charge direction or distribution. Okay, then fourth point, then electric field, that is that should be the total electric field strength spherical cell at an internal point. Okay, that is the important, then internal point is 0. Okay, these are all the application we have to discuss in the last classes. This is the recap of the last video. பார்க்காத நண்பர்கள் லிங்க் டிஸ்கிரிப்ஷனில் கொடுத்துருக்கேன். வாங்க நண்பர்களே, இன்னைக்கு வீடியோக்குள்ளே நம்ம போயிடலாம். ஓகே, டுடே நம்ம என்ன பார்க்க போகிறோம் பார்த்தீங்கன்னா, ரெண்டு தான் நம்ம பார்க்க போகிறோம். டெஃபினட்டாக இதில் ரெண்டுலேருந்து கண்டிப்பாக ஒரு கொஷின் வரும் நண்பர்களே. ஓகேங்களா, One is Poisson equation, another one is a Laplacian equation. Okay. Okay, good. About how to define Poisson equation. About Poisson equation எப்படி எழுதலாம்? So Poisson equation by using from the Gauss theorem, how to write the differential form of the Gauss theorem can be written as then divergent E is equal to, that should be a rho by epsilon naught in this free space. So next style detail இருக்கும். Okay. So the Gauss theorem in the differential form, how to write the divergent E is equal to then rho by epsilon naught. Okay. You see that this is the most important formula by using differential form. Then divergent E is equal to then rho epsilon naught in free space. Okay. The same equation we have to write it in electrostatic field, means we have to write like this, then divergent gradient pi is equal to minus rho by epsilon naught. So in this way, then electrostatic field, how to write? So in these cases we have to write like this. Okay, that should be a okay. That should be a then E is equal to minus gradient pi. So from that before equation, divergent E is equal to rho by epsilon. By using this equation, we have to write like this. Okay, then divergent gradient pi is equal to then minus rho by epsilon naught. Okay. So this is the most one. So about divergent gradient, we have to 2 1 about del dot del pi. About how to write this equation? So about divergent gradient, we have to write del dot del pi is equal to minus rho by epsilon naught, then del dot del square. About del square pi is equal to then minus rho by epsilon naught. So this is the most important equation. Then del square pi is equal to minus rho by epsilon naught. This is called Poisson equation. Okay. So in these cases, then del dot del, which is equal to del square, is known as Laplacian. Okay. So next, Laplace equation. Okay. So then how to define Laplace equation? So in that before equation, then del square pi is equal to minus rho by epsilon naught. So in these cases, if you take, then rho is called charge free region, means then rho is equal to 0, and hence then Poisson equation we have to write in cases of charge free region. We have to put from the before equation then del square pi is equal to minus rho by epsilon naught. In that rho is equal to, we have to put 0, then we have to get del square, that should be a then del square pi is equal to 0. So then before cases from that that should be a before cases in then del square pi, which is equal to minus rho by epsilon naught. Upon we have to take it Laplace equation, then pi is equal to 0. Now we have to put 0, then everything will be a 0. About remaining term, then del square pi is equal to 0. So this is called Laplacian equation. Okay, are you understand? Good. So today what are the points to be remember? We have to discuss today two cases. One is Poisson equation and Laplace equation. So in that Poisson equation, then divergent gradient pi is equal to minus rho by epsilon naught. This is called Poisson equation. Then next one, from these cases we have to put in these cases then rho is equal to 0, then we have to get then del square pi is equal to 0. This is called Laplacian equation. So in the equation எப்படி எழுதலாம்னா then del square pi which is equal to minus rho by epsilon naught. So in the equation la தான் நம்ம 0 போடும்போது here rho is the charge free region. So after that we have to take it, then rho is equal to 0. We have to get this equation, then del square pi is equal to 0. This is called Laplacian equation. Okay. So this is the two things we have to keep it in mind while studying a Poisson equation and Laplacian equation. Okay. So thank you for your listening. I hope this video is useful for those who are preparing a competitive examination and also for relevant students. Okay friends, please like, share and also give your suggestion in the comment section. We have to see in the next video. Thank you.